Hello and welcome to my video, lesson 5.5, Rationalizing the Denominator. So that means that we're taking the radicals out of the denominator and we're trying to make the denominator a rational number. So we're going to have some simple examples to start and then go into more complicated ones shortly. So first of all, we can simplify this. So how can we do that? Well, if we notice to start with that root 8 can be written as root 4 times root 2. Basically just breaking up the 8 into 2 and 4. That allows us to take the root 2 and just give us a 2. So root 8 is 2 root 2. And then we can see that we can cancel out the 2 and the 2. So we're left with 1 over root 2. Okay, so how can we rationalize the denominator though? Because right now we have a radical root 2 on the denominator. Well, if we multiply by that number on the bottom and on the top, then we can rationalize the denominator. So the bottom will now just simply be 2, and the top will be root 2. So this is this is handy because this is exactly the step, if you might recall, from the special triangles rule for the unit circle for angles and finding exact angles. So if you had a 45-degree angle, 45-degree angle in a nice right triangle, the rule was that you could have 1, 1, and root 2, right? So if you think about SOHCAHTOA, so sine would be opposite over hypotenuse. Sine of the angle equals opposite over hypotenuse. And cos of the angle is adjacent over hypotenuse. Right? Both of these were 1 over root 2. 1 over root 2. And we switched that to mean root 2, or sometimes we do root 2 over 2. Root 2 over 2. Both answers are perfectly valid, but it is just interesting to note that we normally write the second version because we don't like to have radicals on the denominator. Alright, so you've seen that before. Let's take a look at this one, which will show up slightly differently. But first of all, we can simplify here as well. So we have 6 and 9, so we can divide by 3 on top and bottom. So it leaves us with 2 and 3. We have root 2. Now we have this here, but we want to have a rational denominator. So what we're going to do is multiply by the radical on the bottom. We don't need to multiply by the whole bottom, but just by the radical. This allows us to have 2 root 2 on top. And on the bottom we have 3 times 2. Now the 2 and the 2 cancel, and so we're left with root 2 over 3 as our final answer. Alright, let's try some more difficult ones here. Here we have a denominator, but it's not just simply the radical, it also has more than one term. And so what we're going to have to use is kind of like our difference of squares when we're talking about like algebra. So if we have x minus 1, x plus 1, what happens is the middle term actually disappears. So what I'm going to show this to you guys right now. So x times x is x squared, right? X times, let's actually not do that. X times 1 is plus x. Then minus x times x is minus x. And minus x times 1 is minus 1. So here you can notice that our middle terms both cancel. And so we're just left with our outside 2 terms. Same thing we're going to do here in order to rationalize the denominator. But instead of going from the difference of squares to a factored version, we're going to go the other way around. We're going to make it a difference of squares. Right now it is not a difference of squares, but we're going to make it a difference of squares by multiplying the bottom and the top by the same thing. We always have to do top and bottom. But we're going to do the the positive version or the negative version, whatever's opposite of whatever's already there, of the denominator. So before it was subtracting by root 3, now it's adding by root 3. By doing this, you can try multiplying it out just to prove that it's true. But same thing as with algebra, it's going to cancel out the middle term, which means that really all we have to do is think about our first term, which maybe I'll do this in a different color here. Our first term is 1. Our second term is negative root 3 times root 3, or negative 3 minus 3. Okay, and the top, we just simply multiply the 2 in, foiling it into place. Okay, so we have a rationalized denominator. However, we can simplify a little bit more. Okay, pretty good. But now we have a 2 on both the top and the bottom, and we never really like to have a negative on the bottom. Just like we don't like to have radicals on the bottom, we don't like to have negatives. So we're going to take the negative. We're gonna basically, I guess we'll divide by negative 2 on the top and bottom. So that gives us over 1, which doesn't matter, but we can write it down anyway. Negative 1 minus root 3 on top. And so this is our final answer here. Alrighty. Okay, let's do this again. And so hopefully, because you've seen me do it once, you can try this one out. So pause the video, try it out for yourself, and see if you get the same answer I do. So what I'm going to do here is do the opposite of what's already there. So it was adding by root 8. So I'm going to subtract by root 8. So what this allows us to do is look straight across and say this is 4. Look straight across, say this is negative 8. And then on top, we'll have to do a little bit more work because there are 2 terms here. So our first one is going to be 6 minus 3 root 8. And then plus 2 root 2. And then minus root 16. Okay, so that's foiling everything out, just like we would in algebra. And now we can sort of start simplifying. So the bottom we can just subtract, and we'll have negative 4, sorry. But on top, we can simplify those radicals. So this would be 4 times 2 plus 2 root 2 plus minus, and the 16 is actually just 4, so we can just put that in right away. Okay, and now we can see that this term here allows us to take the 4 out, and then we just have a root 2. So this would be 6 minus 6 root 2. So that's the reason why there's a 6 there is the 3 and the 2 are multiplying. The 2 from the root 4 are multiplying. Okay, and then 2 root 2. We're going to be able to add those 2 together shortly. And then minus 4 over minus 4. Okay, and we can add the similar terms together. So 2 plus, so 6 minus 4 is 2, plus 6 plus 2, or negative 6 plus 2, so negative 4 root 2, and then we have a negative 4 on the bottom. And so now we can do the same step as the last question, which is divide by the negative. denominator, so divide by -4. Oh, well, we can't quite. We can divide by -2, but top and bottom. So that will give us -1 plus 2 root 2 over +2. And that's our final answer. Took a while to simplify that. This next one will be a little bit more messy even than that one. So let's take a look together here. So we're going to be multiplying by the bottom, but we're going to be multiplying by the opposite sign. So instead of negative, it's positive. Okay, so we're going to do the same thing on top. 2 root 3 plus 3 root 2. Okay, this whole thing allows us to, the bottom lets us simplify quite a bit. Okay, so the bottom lets us simplify quite a bit by getting just a whole bunch of numbers. So 4 times 3 plus minus 9 times 2. And on top, if we kind of alternate the direction of these two, you can see that there's actually some similarities here, but we'll wait on that, and maybe we'll just multiply it out to see what will happen. So that's 8 times 3 and 2, root 3 and root 2, and we have positive 12, root 2, Those are going to be nice to cancel out. Then let's try the next set, which is -6, root 3, root 3. Those are going to be nice and cancel each other out. And then finally, our last one, which is -9, root 2, root 3. And those are going to be nice because they're going to be similar terms to the 8 term. Okay, so this is going to be relatively messy, but we will simplify as much as we can. So 8 root 6. We can leave it just simply as that. 12 times 2 is 24. 6 times 3 is 18. And we can leave the other one as root 6 there. And then on the bottom we have, 4 times 3, so that's 12, minus 9 times 2 is 18. Okay, we're getting to the end here. Just a couple more steps. So -6 on the bottom, +6 on top, and minus root 6 as well on top. Oh boy, we're getting there. We're getting there. Okay, so almost done. Now we just want to maybe we can just divide by -1 so that we can leave it pretty much as simple as we have. Simple as possible here. So that lets us get to 6. So root 6 minus 6 over 6. Alright. I hope this video helped you understand how to rationalize the denominator a little bit better. And good luck!